Verma, chapter photolytic effect and wave particle duality, question number 28. In an experiment on photoelectric effect, the emitter and the collector plates are placed at a separation of 10 cm and are connected through an ammeter without any cell. A magnetic field P exists parallel to the plates. The, the work function of the emitter is 2.39 electron volt and the light incident on it has wavelength between 400 nanometer and 600 nanometer. Find the minimum value of B for which the current registered by the ammeter is zero. Neglect any effect of space charge. Okay. So, question number 28, right? Okay, this distance is given. This is zero point 0.1 meter, and lambdas are incident over here, and the magnetic field is acting downward. Okay, so they have asked the minimum value of B for which the current registered by the ammeter is zero. Look, there is a range of wavelength between 400 nanometer and 600 nanometer. So obviously having less wavelength means having more energy. So the maximum possibility of reaching electrons on the other plate for which the ammeter will give a deflection is for wavelength having minimum value, because when lambda is minimum the energy is maximum. So if 400 nanometer wavelength, when it emits electrons, it has got maximum energy, and if those electrons cannot reach to the other hood, then the deflection of the ammeter will be zero. Is it clear? यहाँ पे एनर्जी इंसिडेंट हो रहा है, तो जिसका एनर्जी सबसे ज़्यादा होगा उसका इलेक्ट्रॉन्स सबसे ज़्यादा एनर्जी लेके निकलेगा. तो अगर वो लोग यहाँ पे रीच नहीं करते हैं तो कोई भी रीच नहीं करेगा. सो यू हैव टू सॉल्व द प्रॉब्लम taking consideration of 400 nanometer wavelengths, because these guys have got maximum energy. So I have the equation Sc by lambda is equal to work function plus Vs is the stopping potential. So I know lambda, and from this ready-made I'll get that lambda put in angstrom, so you'll get the energy. Work function is given 2.39. So you will get the electron, you will get the stopping potential, right? You will get this in electron volt. It is in electron volt. is also in electron volt. So you will get the stopping potential in the form of volt. Okay. So now from magnetic effect, I had the knowledge BQV was equal to mv square by r. Look, here r is t, right? So even you know this EVS is equal to half mv square, right? So mv square is equal to what? 2 EVS. So BQV is equal to 2 EVS by T. So Q is actually electron here, right? So replace Q by E, 2 EVS by T. And you will get the value of V from here. You know E, you know Vs, you know M, mass of the electron. So you will get the value of V. So put the value of V. So the only unknown here is what? B. You have to get the value of B. Hope it is clear.